Hello everyone, today we would like to present our mini project. So for this presentation, we're gonna explain about the flow, how we did this project, and also how this project function. So um, for this project, we're gonna use wind energy as our renewable energy for our project. So, a turbine converts the kinetic energy of the wind to useful mechanical energy. This energy could be used in mechanical form or turn generator turbines and provide electricity. Just like in the hydropower systems, wind energy is harnessed through the conversion of the wind kinetic energy to mechanical energy. The wind turbines are largely classified into two types of horizontal axis wind turbines and vertical axis wind turbines. Large areas installed with the wind turbines, that is, wind farms, are increasingly emerging today.
My name is Pavitran and I will explain about the components that we used for our mini project. Firstly, we used wooden blocks as a frame for the housing of our project. Then we used wires for the connection of the DC motor and the output loads. And the next is this is the main component in our project, which is 12-volt DC generator motor. The 12-volt DC generator motor is a rotary motor which can convert the direct current into mechanical energy or convert mechanical energy into DC power. It means that this motor can interconvert electric energy and mechanical energy. The next main component is propeller blade. The propeller works as a turbine which uses wind energy to drive the rotor and create electricity. This propeller blade consists of four blades connected together by a central hub that attach the blades to the DC motor. We use the USB female port connector. A USB female port is the standard host connector type. This is found in computers, hubs, or any device intended to have peripherals plugged into it. Lastly, we used a USB LED light as our electrical load that can connect to the USB female port.
Hi, my name is Nushaira bint Abdul Jalil. My metric number is B0820102383, and I will talk about the connection of the component and how our project functions. For the connection of the component, we connect the 12-volt generator direct to the female USB pin out by solder wire at the terminal, then install the propeller blade at the generator. This is how our project operates. When the propeller rotates, there is wind and the USB LED lights light up.
Hello, hi. Okay, my name is Muhammad Safi Arif. Okay, so for our mini project output, okay, for voltage we got 1.45 volt. Okay, for current we got 0.5 ampere. Okay, how project functions? Electricity generation. The kinetic energy in wind is converted to electricity by wind turbines. They have used the ancient concept used in windmills with inherent technology such as sensors to detect wind direction. Okay, some wind turbines have braking system to halt in case of strong winds to protect the rotor and blades from damage. Okay, there are gears connected to the rotor shaft to accelerate the blades to a speed suitable for the generator. Okay, inside the generator, electromagnetic induction is the basic method of conversion from mechanical energy to electricity to occur. Okay, the shaft rotates cylindrical magnets against an electric wire coil. All the electricity from the turbines in a wind power station is assimilated to a grid system and convert to a high voltage. This is actually the conventional technique of transmitting electricity in the grid system. That's all. Thank you.
Hi, for this part, I will explain about how project function. I will explain about the propeller blade element theory. The propeller blade element theory assumes that the flow that given part of a wind turbine blade does not affect the adjacent part. This is subdivision on the propeller blade is called annulus. The momentum is calculated for each annulus. All the resultant value of all the resultant value are then summed up to represent the blade and has the entire propeller blade. On each annulus, an equally distributed velocity is assumed to have been induction. Okay, next I will explain about dynamic matching, and this is the last explanation of this mini project. The dynamic flow model was incorporated to improve the estimation by the blade element and momentum theory. The basic dynamic in the flow theory concept help estimate the effect of blade turbulence. The swept area is given dynamic state to help in deriving estimate mass velocity. The BEM theory given estimate only at steady wind, but it's obvious that turbulence must occur. However, this is accountant for the basic dynamic flow model to provide more realistic estimate. Wind energy produced especially in the horizontal axis type is known to be product of tip speed, the total number of the blade used at the lift to drag ratio of the side with aerofoil. The readjustment to the new steady state of equilibrium is well explained by the dynamic flow method DIM. Okay, that's all for our mini project. Thank you.